In our previous video we reached the point whereby we had our stylized MVC framework, and we've created templates for each of the main sections, or most of them. We haven't done the results section. In order for us to move on, we're going to need to create an actual database to store all of this information, which is what we're going to do in this video, and we'll be using MySQL Workbench to accomplish that. In this video we're actually only going to create the main core functionality. As we're going through our templates, we will find that we will need more functionality, and we will create that as we actually need it, rather than creating functionality now which we may not need in the future. So as I mentioned, we're going to create 8 tables within our database. If we start at the bottom right, we can see that we have a ground, and that's where matches are actually played. Grounds have one-to-one relationships with teams, because one team can only be based at each ground, and one ground can only play host to one team. Each team owns many players, and each player, when it's assigned to a team, is called a team player. And so we have our team player and our player tables on the right. It's obviously possible for one player to play for multiple teams, which is why we have this one-to-many relationship going from player to team player. If we move across to the left and ignore the connecting relationships, we can see that a fixture is refereed by a referee, which obviously makes sense given the name. Each fixture contains multiple players, and multiple fixture players can score goals, in which case they would be recorded in the goal scorer table. If we look at the relationships which cross from left to right, we can see that teams can play in multiple fixtures. In our fixture table, we're going to have both the home team. In our fixture table, we're going to record both the home team and the away team for each fixture, which is why we have 2 relationships here. We also have a relationship to describe the fact that we have team players who may play in multiple fixtures. It's entirely possible that a team will own a player who will never actually play a competitive game, which is why this relationship is optional. When it comes to actually identifying who's won a game, we will actually just use the goal scorer table primarily to identify how many goals have been scored for each team, and this will then determine the winner, which will obviously inform the points, and then this information will all roll up eventually into our league table. This may be somewhat counterintuitive, because you may expect that we would actually record the results in our database, but it's entirely possible that a referee, when they're recording the goal scores for each game, will make a mistake. If they do make a mistake, we don't want to have to recalculate every single part of the database. We want the database to do that itself for us. And so by not recording the actual winner, loser or draw status of a fixture, we're able to relieve ourselves of a lot of work. So if we move across to MySQL Workbench, the very first thing that we're going to do is to create a database, which we're going to call League. And we're going to select that we want to use that as our actual current database. So the very first table that we're going to want to create is the grounds table. I'm going to try and format these creation commands so that they are quite readable, but you don't need to worry too much about the formatting yourself if you are following along. So the first thing I'm going to do is to list all of the data which we're going to store within each table. So in the grounds table we're going to have a ground ID. We're going to have the ground's name. We're going to have the ground's address and the ground's capacity. The next thing we need to do is obviously to select the data type for each of these. So as you say, I'm going to keep this quite tidy, but you don't need to worry about that if you don't want to. So we're going to set the ground ID as an integer. The ground name is going to be a varchar, and we're going to set that to 75 characters long. We're then going to have the ground address, which again is going to be a varchar. We're going to set this to 100. Finally, we're going to have the ground capacity, and we're going to set this as an integer as well. So we're also going to want to set a few more properties. So for example, we want to set the ground ID to auto increment, as well as setting both the ground name and ground address to not null. And finally, we're going to set the primary key of the table to being the ground ID column. So if we run this command now, we're going to create the table. I'm just going to comment this out so that we can refer back to it later on. And we can describe our new table. Which will show all of the information that we've just selected. If we wanted to, we could go back and change these to integers being lower than 11. But for our purposes, we're not going to worry too much about that. So the next table that we're going to create is going to be the player table. The player table is going to be very simple in its construction. We're just going to have a player ID and the player name. If you really want to, you could add more detail into here, but for our purposes it's not going to make any difference. So we're going to set the player ID to be an integer and the player name to be a varchar. In this instance, we're just going to set it to be 30 long. We're also going to set the player ID to auto increment, as well as setting the player name to not null. Again, we're going to create a primary key for this, which will be our player ID. So if we execute these two commands now, which will create our new table and show us our table in the describe view, we can see that the table's been correctly created. I'll just remove those comments. Next up, we're going to create our referee table, and this is actually going to be remarkably similar to our player table. So I'm just going to copy this across. So if you execute this command now, we're going to create our new table. Oh, that should be referee ID. I'm not going to bother displaying it because everything's the same as our player table. Now you may notice that we're actually working basically from outwards to inwards. We're going from the tables which are going to always be the one end of a relationship towards the tables which have multiple ends of the relationships. And this way we don't have to worry about foreign keys because we will already have the tables created before we create our foreign keys, which is something that we're going to do within the next table. So the next table that we're going to create is our team table. So within our team table we're going to have team ID, team name, the team manager, team contact number, the team crest, and the ground ID. The team crest, in case you're wondering, is going to be the logo for the team. Our team ID is going to be an integer. Our team name is going to be a varchar, which we're going to set to 75. The team manager is also going to be a varchar, which we're going to set to 30. We're going to set our contact number to char of type 11. Because this is going to be a UK based league, the contact numbers are always going to be 11 digits long and they can begin with a 0. And so we want the fixed length of 11, and we can't use an integer because of the leading 0. If we used an integer, it would actually remove that leading 0 for us automatically. The team crest or the team logo is actually going to be a link to our website which contains the actual picture for that team. And so we're going to set this as a varchar of 75. But we may need to review this later if the links that we're going to link to are particularly long. Finally, the ground ID is going to be an int, because that's what we've created when we've created our grounds table up here. So again, the next thing to do is to create our constraints. We're going to set the team ID as our primary key. And then we're going to add some more constraints to our ground ID so that we can actually refer to the ground ID in our ground table. So I'm just first going to set a constraint to make this an index. And I'm then going to set a constraint to create a foreign key. So all we're doing on this final line is setting the foreign key for this table to this ground ID which we've created here, and it's going to refer to the ground table, specifically the ground ID element within that table. So if we run these two commands now, we'll create our table as well as all of the constraints that we've added in, including our foreign key. So I'll just remove all of this. Next up, we're going to create our team player table. This is just going to contain the team ID, the player ID, and that's it. All we need is the actual IDs, because if someone changed their name, we don't want to have to change everything else in our database. Both of these are going to be integers, because that's what we've defined them as in our actual tables. We want to set both of them to not null. And then we want to actually go ahead and implement our constraints of our own keys. The naming convention is going to get slightly long because we're obviously referring to tables which have multiple elements in them already. I'm just going to set the team ID to refer to the team table, specifically the team ID column. The final constraint that we want to add in is for the player ID. And instead of referring to the team table, we're going to refer to the player table. And we're going to link the player ID to the player table, specifically the player ID. Finally, we want to create our primary key for this table. And so we're going to set both of these keys as being our primary key, which can also be called a compound key. And the way to do that is just to actually list both elements within this final bracket. Obviously with a comma separating them. So if we go ahead and describe this table as well. And execute both of these commands. We're going to see that both of these have been set as the primary key, and they're also linked across to our other two tables. So we just have 3 more tables to create. So the next one that we're going to create is the fixture table. In here we're going to have a fixture ID, fixture date, a fixture time. We're going to have the home team's ID and the away team's ID, as well as the referee's ID. So we're going to be linking to multiple tables in this occasion. And you can see that these two, the home team ID and the away team ID, are going to link to our team table, which is how we get the actual 2 relationships which we displayed on our entity relationship diagram earlier. So our fixture ID is just going to be an integer. Our fixture date we're going to store as an integer as well. So too we're going to store the fixture time as an integer. And the fixture and the home team ID is going to be an integer. And the away team ID is going to be an integer. And the referee ID is going to be an integer. So you can see already that because we're referring to these other tables, we're not going to actually store any data that we don't need to within this table. We're just going to store the IDs. And when we come to actually referring to these tables later on, we're going to use joins so that we actually get the data out in the formats that we need it in. This also has the added benefit of making the database a lot smaller in terms of size, because we're not storing the same data twice, and the format using integer is one of the most efficient. So the next thing we're going to do is to set this as an auto increment, and then every other field is going to be not null. We're then going to add in our primary key. And so we just need to add foreign keys for our home team, our away team, and our referee ID. And so the home team foreign key is just going to be called foreign key 1. It's going to be a foreign key on the home team ID, which will reference the team table, specifically the team ID. We're just going to copy this across because our away team ID is going to basically be the same, except it's going to be called foreign key 2. And it's going to be the away team ID that we refer to. Finally, if we copy the foreign key across again, we should actually name these fixture team, so that when we're referring to these again in the future, we know exactly which one we're referring to. So we're going to correct the referee ID to the referee table, specifically to the referee ID. And you can see that because we've got multiple tables connected here, our tables are actually getting more complex. So if we do the same again here and create the table and describe it, we have an error in our SQL because we have this extra comma, and now everything is correct. So next up we have the fixture player table. And again, we obviously couldn't create the fixture player table without first creating the fixture table and the player table, which is why we're creating them in this order. So we're going to create the table, fixture player. We're going to create the fixture ID, player ID, the team ID, and that's it. As you'd expect, these are all going to be integers. And we're going to set all of them to not null. Our fixture ID is obviously going to come from our fixture table, and so we're going to copy this fixture constraint across, just so we don't have to keep typing it. So you can see that the naming convention is the current table, then the table that we're linking to. And we've been doing this throughout. So our fixture ID is going to be connected to our fixture table, specifically to our fixture ID. Now we can also save ourselves some time. Because we have both of these elements which are connected to our team player table, you can actually link both of these at the same time. And to do that, we just need to create both links separated by a comma. And then both elements that they're linking to, which are going to be the same thing. And then before we create this table, the last constraint that we're going to add is to create a primary key. Interestingly though, we're going to use all of the elements within this table to create our primary key. And so we're going to have a three-way compound key. And so if we change this to output the correct table and run these commands, we're going to get our new table created properly. So if we go ahead and comment out this table again, and the very last table that we're going to create is our goal scorer table. This is actually going to have the same elements in it as our fixture player table, so I'm just going to copy these down. And so to create our foreign key for this, we're just going to copy this foreign key across from here. And remove this last comma. So what we're going to do is change this to goal scorer. And remove the team player table. We're going to add in our fixture ID. We're going to do that over here as well. And we're going to change this to fixture player. And as you can see, our table's been created for us. So again, I'm just going to comment out this code. And I'll include all of this section in the GitHub file, so that when you come to do this yourself, you don't need to type everything out yourself. And so if we just type show tables now, you can see that we've created all of the tables that we intended to create. All 8 of them, which are all connected properly using the foreign keys which we've created. In the next section, we're going to look at creating a link between our PHP and our MySQL database, so that we can actually access and use the data from our database within our PHP code. And then when we've created that connection, we'll be able to start working on our templates in a lot more detail using actual data. We're going to need actual dummy data in this database though, so that we can actually know what we're working with. And so off camera, I'm going to go ahead and populate all of these tables, so that when we actually come to manipulating the data, we have actual data to manipulate. So make sure to subscribe. So as we can see, we already have this player 301, whose name is J Smith. If we refresh this now, we get our boolean true because we've changed our record, and we can see by selecting the data that we've changed it to an example.